Hello from West Virginia. I'll get there someday. But what I do have is joke of the day, and I know that you're ready for it. So you know what? I would tell you a joke about chemistry, but I know I wouldn't get a reaction. Because there's reactions in chemistry. Anyways, let's react to applications of linear equations in two variables. So I'm going to show you why we've been working through all these things that we've been working through. There are tons of applications for linear equations in two variables, and I have just a couple here for you. So in each of these two examples, we're going to write an equation that represents the situation, and they're going to transform that equation into slope-intercept form and into standard form. So in this first one, we've got this printer company. A printer company charges $65 to print 100 copies of this booklet. But it'll also charge $105 to print to print 500 copies. So we want to write an equation that will get us this relationship so that we can figure out, okay, any number of copies that I want to print, how much is it going to cost me? So the equation will really help for us to be able to just quickly say, all right, here's how many copies I want, spit it into the equation, that's going to tell us how much it's going to cost. Rather than go with this kind of thing that I've got. Now, it's very important that it says it assumes that the relationship between the number of copies and the cost is linear. Linear means straight line, and it's very important that this relationship makes that straight line, because if the relationship makes this curve like this, there is no way for us to figure out how much each, like if I want 400 copies, how much is it going to cost? That's very difficult. I mean, there's a way to figure it out, but it's pretty difficult and challenging. So we're grateful that that relationship is linear. So what I have here is a couple of variables that are happening. One of those variables is the cost. The other variable is going to be the number of copies that are printed. So I can look at this idea of this relationship and I can say, okay, if it's going to cost me $65, then that means that I can get 100 copies of the booklet. And by the same token, if it's going to cost me $105, then I can get 500 copies of the booklet. So in other words, the relationship is, let's call the cost X, and let's call the number of copies Y. Now, I could have flipped it around, and I could have put the number of copies as Y and the cost as X. It would have been completely fine. You just need to define what that variable is. So let's let X equal the cost, and let's let Y equal the number of copies. And so now I can figure out what that relationship is or I can figure out the equation for this because I have 2 points. And so we've been looking at utilizing that point-slope form of the equation of a line in order to be able to take 2 points and write that equation. Now you know that you've got to get the slope, whether you're using slope-intercept or whether you're using point-slope, you have to get that slope. So let's start there, and in order to get that slope, you know that that means you need to subtract the y's on the numerator, subtract those x's on the denominator. So what I'm going to do, and it doesn't matter the order you subtract the y's, we've established that, just make sure you go in the same order on the x's. I'm going to do 500 minus 100 because that's a little bit easier to work with. And then that means that I'm going to do 105 minus 65. Well, 500 minus 100 is 400, and 105 divided by minus 65 is 40, giving me a slope of 10. So now what I can do is, do I have that right? Yes, I do have that right. Okay, so now what I can do is I can establish that point-slope form of the equation of the line, and the point-slope form says y minus y1 equals m times x minus x1. And so now what I have is, remember, I took the subscript off of this one to remind me that it stays as a variable, took the subscript off of this one to remind me it stays as a variable. Now I can pick either of these 2 points, it doesn't matter which one you choose. I'm going to go with the top one, which means my y is going to be 100, and we figured out that that slope was going to be 10, and the x is going to be 65. So in terms of writing the equation of the line representing that relationship, I'm done. There's no cleanup to be done. Remember, cleanup would be subtracting a negative is really adding a positive. I don't see anything like that in here So here we have the point slope form of the equation of the line. But now remember, we were told translate this into slope intercept form, translate it into standard form. So when I translate it into that slope intercept form, remember, I need to make sure that the y is by itself and that there's no parentheses. And you guys know that I can either add that 100 and then distribute, but I'm going to distribute first and then add the 100 to prevent me from distributing too far. So let's distribute first, giving me, that's 100, excuse me. There we go, that's 100, giving me 10x minus 650. And now what I'm going to do is add that 100 to the other side, giving me, and when I add 100, then I'm going to get a negative 550. So there it is in slope intercept. And then finally, we were told now, write that in standard form. Remember, standard form has 3 criteria. No fractions or decimals, don't have any anyways. Get the x and the y together on one side and make sure that the x coefficient is positive. So I'm going to slide the x over here and subtract it off. That'll give me a negative 10x plus y equal to a negative 550. And now I'm going to change all the signs, giving me 10x minus y equals 550. Ta-da! There it is in standard form. And like I said, the beauty of this is that I can say, okay, if I want to have 200 copies, how much will that cost me? Well, the copies was my y, so I can choose any of these equations and I can say, well, I'm going to put a 200 here and solve for x. I'm going to put a 200 here and solve for x. Or I'm going to put a 200 right here and solve for x. Or let's say that I have a budget and I say, I only have $50 to spend. How many copies can I get? Well, then I can put $50 here and figure out how many copies by solving for y. Or I can put 50 here, same thing, solve for y. Or I can put 50 right here, same thing, solve for y. So these equations are very helpful in terms of me being able to figure out very quickly, if I want this many copies, here's how much it's going to cost. Or here's my budget, this is how much money I have to spend, how many copies can I get? And remember, I've stressed this to you before, and it's really true. What's circled in green, what's circled in blue, what's circled in orange, they all mean the same thing. It's just 3 different names for the very same line. They really are all essentially the same equation, just different formats of the same equation. Like my name is Lori James, or I could write my name James, comma, Lori. I'm still me. It's still the same person, just a different way to write my name. So let's take a look at another example. Okay, so you can see in this example we're dealing with healthcare. We have blood pressure tends to increase with age. Unfortunately, it's true. Suppose the normal blood pressure of a 20-year-old is 120. And that of a 50-year-old is 135. We want to assume that the increase is a constant rate, and like I said before, that is very important because if it increases at more something like this, very difficult to figure out the equation. And even so, a linear equation, we need that constant rate of change. So it's good we see that. So here again, we've got this relationship that is being established, and the relationship is that we've got age and blood pressure. So we can say, okay, let's group them up. 20-year-old has a blood pressure of 120, and a 50-year-old has a blood pressure of 135. So the relationship that we're establishing here, X is going to be the age, Y is going to be the blood pressure. So let's define that. Let's let X equal the age, and let's let Y equal the blood pressure. And so now, like we had before, I have a couple of points that I've got established. When I've got those 2 points, I can write the equation of the line pretty easily. But we know that we need to establish that slope, whether we use slope intercept or point slope, you've got to get the slope. You've always got to have the slope. So we're going to do subtract the y's on the numerator, subtract the x's on the denominator. And like I've said a million times, doesn't matter the order you go with those y's, go in the same order on the x's. To make my life easy, I'm going to do 135 minus 120. Now if I go in that order, that means on the x's I have to do 50 minus 20. Now 135 minus 20 is going to be 15. 50 minus 20 is going to be 30, giving me a slope of 1/2. Now I'm going to utilize that slope, and like we said before, I've got 2 points to choose from, but when I've got point and slope, We know that means point slope. That's why mathematicians are not creative people. Thank goodness we tell you what you need to do. So point slope looks like this. Y minus y1 equals m times x minus x1. We took the subscript off of this one to remind me that it's going to stay as a variable. We took the subscript off of this one to remind me it stays as a variable. And I can pick either one of the two that I want. I'm going to go with the top one. So y minus 120, my m is 1/2, and my x, if I'm choosing the top one, is going to be 20. Is there any cleanup that needs to be done, like subtracting a negative? No, there certainly isn't. So therefore, we have it, point slope. Ta-da! There it is. But remember, we need to turn it into slope-intercept. So in order to turn it into slope-intercept, what we're going to do is get the y by itself, get rid of the parentheses. Now, like I said before, I could slide the 120 and then distribute, but I prefer to distribute first to keep me from making mistakes. So I'm going to distribute my 1/2 through, and 1/2 of 20 is 10. And now I'm going to add that 120 to both sides. And when I do, I get a 1/2 x, and when I add 120 over here, I'm going to get a 110. Ta-da! Parentheses gone, y by itself. This is slope-intercept. And now the last thing that I have to do is turn this into that standard form. We know that's 3 criteria. Get rid of the fractions, get x and y together, and make sure the x is positive. Most people like to get rid of the fractions first, so I'll go ahead and do that. What's making it a fraction is that 2 in the denominator, so I'm going to multiply absolutely everything by that 2. And when I do, I get a 2y equals x plus 220. And now I'm going to slide that x to the other side to get it with the y. When I subtract it off, and remember that 2y is positive, the 220 is positive, and now I just need to make sure the front coefficient is positive. It's negative, so remember I'm going to multiply every single term by a negative or divide every single term by a negative. Basically, I'm switching all the signs. And so there we have it. That is your standard form. And like I said with the previous example, the nice thing about this, even though all 3 of these equations represent the very same line, they all represent the same relationship, the nice thing is I can say, okay, I am, and I'm not, I'll be 50 here in 6 months, but I can say, well, I'm 30. What should my blood pressure be? And so I can say, well, that was the x, so I can put a 30 in here, solve it for y, that's what my blood pressure should be. Or put my 30 in here, solve for y. That's pretty easy because half of 30 is 15, 15 and 110. My blood pressure should be a 125. Or I could go with this one and put a 30 right in here. Or I can say, okay, my blood pressure is 200. That's the equivalent of what age? And I would put 200 in here, or 200 in here, or 200 in here, solve for x, and that tells me what the equivalent age should be to see if I'm in the right area. Again, great application of linear equations in 2 variables. So many other applications, but hopefully these 2 show you that it's not just a business application, it's not just a healthcare application, and there's so many others. So I hope that helps. Have a great day.